Okay, here we go again today. This is a nice, this is much easier and less involved lesson than lesson 2. Lesson 3, radians. Okay, first let's do a little warm up because this is what we're going to be doing quite a bit of. A little unit conversion is what the main part of this lesson is. We're going to be converting from radians to degrees and degrees to radians. Radians is another way to measure rotation, just like degrees is a way to measure rotation. And so we're just going to be doing unit conversion, which, you use this a ton in chemistry. I remember that, right? So let's just go with old, here we got a ruler. I've been doing a little building with my kids, building a little bunk bed. So inches and centimeters. Okay, inches is American units. And centimeters is international. So there, in 1 inch, you can see it on the thing here, 1 inch is a little over 2.5 centimeters. So like go from 2 to 3 here, 1 inch, that's 5 to 6 to 7 and a little over halfway to 8, 2.54 centimeters. So real quick, I would like for you to pause this video and solve 12 inches equals how many centimeters, and write down how you solve that, okay? And then go from centimeters to inches, because today we'll be going from radians to degrees and from degrees to radians. So solve 12 inches equals how many centimeters, and how many centimeters, 100 centimeters equals how many inches. Okay, ready, pause. Okay, back here, I'll do this. What I would like to do today is see that since 1 inch equals 2.5 centimeters, I can either divide both sides by 1 inch and I will get 1 inch divided by 1 inch gives me 1, right? Leaves me with 1. 1 equals 2.54 centimeters per 1 inch. There's another way to write inch, this two little marks there. Okay, or you can go the other way. If I divide both sides by 2.54 centimeters, then I'll get 1 equal 2.54 divided by 2.54. I get 1 equals 1 inch divided by 2.54 centimeters. Okay, then you just have to say, well, which do I want? I'm wanting to go from inches to centimeters, so I'm going to multiply 12 inches times, I want centimeters on top and inches on the bottom, so I'm going to use the conversion 2.54 centimeters over 1 inch. So you use this a lot, this idea, because this is 1, right? So I'm multiplying 12 inches times 1. It's not changing it. Changing the way it looks is changing the units. So I'm dividing inches by inches and I wind up with centimeters, okay? Centimeters on top, that's what I want. I would imagine you've done this in chemistry or science classes a bunch. So you can use your calculator, right? It's going to come out to about 30. 12 times 2.54 equals, what? I must have been using this calculator for something else. Okay, 30.48. And depending on what you, let's just go with 30.5. Okay, whatever. Right at 30 centimeters. Okay, so let's convert the other way. So you just pay attention to your units again. I want to go from centimeters to inches, so I want my inches part of my conversion on the top. Centimeters times, I want the inches up top, so 1 inch per 2.54 centimeters. So this time I'm dividing by 2.54, right? 100 times 1 divided by 2.54. So Yeah, so just 100 divided by 2.54, what does that come out to be? 100 centimeters is 100 divided by 2.54. 39 I'll just go with 39.4. 39.4 inches. Okay. That's just our little warm-up, because it's what we're going to be doing. We're going to be gluing together our degrees that we've already messed with. So I drew this circle. Ooh, it barely fits in my little window here of my thing. And what a radian is the distance that I will turn around a circle if I take the radius and lay it on the circumference. So I got these little pipe cleaners. I thought this was my kids were playing with pipe cleaners, so I thought, hey, maybe we can represent this. So I got the radius of this circle is 1 pipe cleaner length, right? And so I lay one up there. How far do I go around? Well, it's more than 0, less than 90, somewhere in the first quadrant. If I keep laying them around here, I'll try to keep this on here. Maybe this will work out all right. Okay, there's a second radian. Let's do a third one. This is not perfect, but hey, it's perfect enough, because we see with 3 of these, with three and a little more, we would be halfway around the circle. What famous number with circles is a little more than 3? All right, so let's keep going around the circle. We don't have to keep going around the circle. I guess we're proving our point here, I think. Keep going around. You would almost go it with 6 radians, get you close to being all the way around the circle. There's 5 radians. And 6 and a little more would get you almost around the circle. So, okay, so the big one is that 3 radians get you almost halfway around. Okay, so what is halfway around a circle in degrees? Okay, you're probably already making this connection. Okay, so here we go. Let's try this. I'll keep it on this page. I've got a second one drawn, but so this is a radius right here, the radius of the circle. And if I have 2 radii, if I go 2 radius, I get what? So the diameter of the circle equals 2 radii, right? Okay, what is it? Since we're using the circumference of the circle, and we're rotating around the circle on the circumference. We're traveling around the circle on the circumference. What is the formula? Do you remember the formula on the circle that relates circumference and radius? The circumference of a circle is that magic number. Is the diameter, if I take the if I take the radius, which is half the diameter, and a little more than 6 gets me all the way around. So diameter times a little more than 3 is the circumference of any circle. And that magic number is pi. So the circumference is, if I substitute in 2 radii in for diameter, I get 2 pi r. 2 radii times pi. Okay. So and so now, so the whole circumference of the circle is 2 pi times the radius. All right. Now let's look at. And this is radians. So this is in radians. This is how far we got. 2 radii, 2 radians, 2 pi times the radians. Almost 6 of them, right? I mean, a little more than 6. So what is the circumference in degrees? If I went on 1 full rotation is 360 degrees. So here we are. We've got our 2 pi radians equals 360 degrees. Okay, so that's how you get to this conversion factor. So then if I divide both sides by radians, so I'll have you can go either way. I'll have 1, just like our unit conversion, 1 equals 360 degrees divided by 2 pi, and that's the same as 2 pi radians. This is degrees. Sorry, there's our units, just like inches and centimeters. This is degrees is one way of measuring rotation, and radians is one way of measuring rotation. So 2 pi radians is the same as 360 degrees. And it's more useful, I believe, to divide both top and bottom by 2, and you get 180 degrees. Halfway around the circle is the same as pi radians. So 1, here's our conversion factor, and I think you can do all the problems. And I apologize for this video being so long. And pi radians divided by 180 degrees. So that's our conversion factor that we'll use. Okay. Next video I'll give you do a couple little problems to do, and that'll be lesson 3. All right. Thank you for your attention. I know it's a little long.